So good morning everyone, myself Gagan MM. Today we are going to discuss about Mosfet characteristics in the Pragna unit. It is the kit which is provided by Pragna. I will hold your study, take the screenshot of the circuit. Okay, let us now discuss. We are using Mosfet IRF 740, and this is the front panel details of the given circuit board. Next, and the back panel details is given that 2-pin main cables, fuse holder and fuse of 500 milliamps. First we are going to discuss about the characteristics of the MOSFET. The circuit is same as connection has been done, and the device circuit diagram and device IRF 740 specifications is given. First, in this circuit we are going to connect, there are two main supplies, V2 and V1, which is variable, and we are using a MOSFET. So the MOSFET number is IRF 740, whose gate terminal is connected to V2 of the positive, and the source is connected to the ground, and VGS is connected across the gate and source. Another point, which is drain of the drain point of the MOSFET, is connected to the negative of the milliammeter, which is graded for 0 to 2 amps. And the positive is connected to variable resistance. Here in this circuit they have given the fixed resistance RL, which is load resistor, but in the circuit has given that RA, and we have to consider the voltage across the drain to source, which is positive and negative, which is graded for 0 to 200 volts, and another one is V1, which is a variable power supply, which is also connected to ground. Next, in this we are going to see the characteristics of the MOSFET in this circuit. Here we are going to tabulate in the tabular column first V1 and V1, which is a VDS1 here shown. We will make it as 10 volts. Then we will measure the voltage across the gate to source, and then we will go to the we will check whether how is voltage is varying with respect to time. In the ideal characteristics of the MOSFET, this is the graph. We will have for 10 volts this is much, and if we take the another reading, for VDS is 30 volts or 20 volts with respect to your suitable given voltage, we have to vary with respect to time. VGS, as we increase the voltage, the difference has been noted. This is the ideal characteristics. We have to match it in the experiment setup. See, this is the circuit. I will hold it, take a screenshot of it. Okay, now we will turn on the circuit. Now, as per the shown figure, we have done the voltage VDS is 10 volt. We are calculating for the 10 volt. Now, in the circuit shown that for VDS we have put a 10 volt. Here they have shown that VL, which is a load. Across the load, across RL load, we have VL, which is voltage across the load. Here given that VDS, which is gate to source, which is near to this RA, so we have taken that VL. VL is varied using the V1, approximately set it to the 10 volts. Then vary the V2 with respect to it. Note down the IL, note down the VG with respect to the IL. See, it is varying in this circuit. They have given that 2 to 5 volts. 2 to 5 volts vary it. We will get the tabular column. So vary it. As we go on increasing, the voltage the current IL is varying, which is in amps. Now it is showing 12 amps, so which is approximately equal to 12 milliamps, because the point is given here. It is 12 amps. If we convert it into the point something ratios, then 12 milliamps will be shown. So we will vary up to 5. Note down the points with respect to a suitable tabular column consistent. If you have to take on the 5 readings or 2 readings or 10 readings, vary it with respect to it. Then vary it up to 5. See, now it will gradually increase in the 10. It will gradually increase if we vary it very slowly. then it will go constant. See, above 8 it will not go. 82 amps is the maximum. It will gain the maximum voltage, then it will be constant. Same, it will gradually increases, then it will be constant. Saturation region will be achieved. This is all about MOSFET characteristics. We have taken the readings. It will be the it might be for you it can be vary, but it is our reading for 10 volt, and we have taken for 20 volt. Thank you. Okay, up to now we have learnt about the transconductance characteristics of the MOSFET. Now we are going to learn about drain characteristics of the MOSFET. Here they have given the procedure. You can learn it, take a screenshot. Okay, in here same circuit. For the ideal drain characteristics of the MOSFET is this. We have plotted the graph across VDS and ID in milliamps, and taken the VGS approximately for 3.5 volt, 3.6 and 3.7. They have taken. You can vary it, but ideally it will give the perfect approximate and good result for these voltages. I will suggest you to take these voltages for as a VGS. Now in the circuit, we have been taking the voltage VGS across 3.5 volts. So 3.5 volt has been set for VG. Then we will vary. Okay, we will vary VDS. We will vary VDS, which is we will vary the VDS with respect to the ID in milliamps. We have taken the VGS as a 3.5 volts constant. So if we vary this one, I suggest you to very slowly, because up to maximum 2 volts it will vary, and it will gain the constant voltage. So if you vary, see, for 0.5 volts it is showing that 26 milliamps. So vary it very slowly. You will get the tablet. You can tabulate the column with respect to that, and you can have the values up to 10 to 15 tabulated values. So vary it very slowly. For 1.1 it is 27. Reduce it. See, from 0 it is varying. For 0.2 it will 70, 26, gone, 20 increases, and it gain constant. Up to 2 volt it will gain constant. This is all for the drain characteristics of a MOSFET. Thank you.